Thank you, Mas, for the nice introduction of me and my work. And I'm going to present our paper, which is in general about developers' experiences, leaking code secrets to the public. And I'd also like to thank my co-authors contributing to this project. So to collaboratively develop software, version control systems are essential. While there are different version control systems, Git is the most used version control system, especially Git-based platforms such as GitHub or GitLab. They are widely used to share source code with other developers. And to deploy software, automate interactions with third parties, or most common to handle authentication, developers need to provide and handle secrets securely. Secrets like credentials, authentication tokens, or secret encryption keys are highly sensitive information. And leaking those can, for example, lead to unauthorized access, data theft, or the abuse of server resources, so you want to handle your secrets securely. And here are some examples from the recent years. And what we can see is that even big companies, such as GitHub, experience code secret leakage. Every year, code secret leakage becomes more and more prevalent. GitGuardian, which is a code security platform, continuously analyzes GitHub for leaked secrets. And in their Secret Sprawl report from 2023, they reported that the amount of code secret leaks on GitHub increased by 10 million secrets. 5.5 comments out of 1,000 exposed at least one secret. And regarding developers that leaking those secrets, 1 in 10 authors exposed a secret in 2022. And there's also some related work. For example, Millie et al. Conducted a large-scale measurement study on secret leakage in public GitHub repositories, finding that more than 100,000 repos contained leaked secrets. So let's come to our research questions. First, we were interested in how widespread code secret leakage is among developers. Followed by the question, what approaches developers use and what developers' experiences are to prevent code secret leakage. And of course, we wanted to know how developers reacted to code secret leakage incidents. And what they did to remediate the incident, including the experiences on used techniques and tools. To address our research questions, we conducted a mixed method study. First, we conducted an online developer survey, followed by online developer interviews. In total, 109 developers participated in our survey. We recruited 50 freelance developers from Upwork and 59 developers from GitHub. And we also piloted our questionnaire and the recruiting material, and of course, we got IRB approval for both studies. The questionnaire contained several topics, like source code management, experiences with secret information, developer threat models regarding sharing secrets, remediation, prevention approaches, and demographics. In this talk, I can only present the remediation and prevention approaches emerged from the survey. Our goals to identify the extent of code secret leakage and getting to know what code secret leakage prevention and remediation approaches were actually used by developers. To deepen the qualitative insights, we conducted additional 14 online developer interviews with developers from GitHub. Because we were interested in the experiences with code secret leakage, our recruiting criteria was that developers must have experienced code secret leakage in the past. Within the interview, we asked participants on their experiences with code secret leakage incidents and their remediation and prevention approaches. With these interviews, we aim to identify developers' problems, challenges, and needs with code secret leakage remediation and prevention approaches. And in addition, we wanted to understand why code secret leakage is happening. So now we'll present some findings from our survey and the interview study, but due to the time limit, these findings are only a selection of what we found out. So please take a look at our paper to learn more about our research and our findings. So a third of our survey respondents reported that they have leaked secrets by themselves. And even more survey respondents reported that they know other developers that leaked code secrets to the public. Our interviews reported that secrets were mostly leaked through public repositories. And in addition, secrets were also leaked in restricted repositories, for example, company internal self-hosted GitLabs. Besides that, interviews reported that secrets were leaked on code sharing platforms like Pastebin or GitHub Gist, or even in the GitHub workflow logs. Interviews reported on different types of secrets that had leaked. They reported to have leaked configuration faults, API tokens, access keys, and database passwords. In addition, one participant said that they leaked their whole password manager database to GitHub. And this database was not protected, so it contained all secrets, and yeah, they were leaked to the public. And depending on how fast you can identify a leaked secret, the consequences may be worse, or you can prevent having any consequences. Most interviews were notified through the GitHub secret scanner, which notified developers quickly, and sometimes it has revoked the leaked secret. They have also reported that leaked secrets were found randomly, sometimes when working on another task, or they got notified by other developers or researchers that saw the leak in the repository. Besides that, one interview reported that it took weeks or months to discover the leaked secret. And of course, this was not amazing. As a consequence for the company or the software team the interviews were part of, code secret leakage causes additional workload to remediate the leak or financial or reputational damage. Regarding external stakeholders, these may be affected by data loss or data theft. Regarding the root causes of code secret leakage, our interviews find that root causes are having no awareness. Especially new developers who joined a software team, as one participant stated, that the biggest contributor to secret leakage is the human factor, and that no prevention approaches at all were used or in place before the first incident happened, and that they are not using or misusing, for example, the .gitignore file. And, of course, developers had hard-coded secrets in source code. And developer threat models and the secret access process, for example, a participant stated that you'll just have to ask to get access to whatever you want. We identified several remediation approaches that emerged from the data analysis of our survey respondents. It was most common to invalidate leaked secrets to prevent any further misuse, followed by removing leaked secrets from the version control system's history, an example by rewriting the history, cleaning caches, or reinitializing the whole repositories, and analyzing the leak to identify the root causes. Our interviews reported several challenges when remediating code secret leakage. First, they'd say that the process of remediation is cumbersome, and that it is even more complicated to remediate when the incident's response process was never tested before or trained before. In addition, they were afraid of not being aware of all the consequences that may be caused by the leak. And finally, they found it too complex and time-consuming to select, learn, and apply different or multiple remediation approaches. After we talked about incidences and the remediation, wouldn't it be better if incidents were less frequent or even non-existent? To do so, several respondents used different approaches to prevent code secret leakage. Mostly, they separated code secrets from committed code, so that secrets are loaded at runtime. For example, they stored secrets on a central server or a secret management system, or they used environment variables. To prevent code secrets to be contained in code, config, or any other files, or prevent including them in publicly available source code repositories, for example, by using the .gitignore files, minimizing secret usage in general, or at least use non-secrets, or remove secrets from version control before pushing them to the public repo. And if secrets need to be used or need to be shared through the repository, they should be encrypted. We identified several factors participants reported that influence the use of prevention approaches, including specific tooling. They more or less reported common usability goals. So the approaches have to be effective, efficient, secure, usable, but also compliant with company requirements. In terms of prevention approaches, respondents struggled with time constraints, and time often equals costs. They reported it to be challenging to invest the time needed to set up a new approach. And if an approach should be successfully applied by team members, all the developers from the team need to be involved in training. They also reported on extensive refactoring work required to incorporate new approaches into existing projects. Another major challenge is to train developers and make them aware of code leakage. As one participant said, someone did something off the books. Another repository, he created another repository outside the organization, and then the code and the secrets were pushed to the public. The participants believe that this behavior cannot be fixed with additional tooling. Instead, developers need training or a strict policy. Finally, we'd like to provide some recommendations that emerge from our analysis for both developers and service providers. Ideally, developers do not leak any secrets. To decrease the likelihood of code secret leakage, we recommend a combination of different prevention approaches. Separate secrets from the source code or externalize secrets from the repository, an example using the environment variables instead of hard-coding secrets into the source code. Avoiding that these secrets are pushed to the repository by, for example, using .gitignore files. Monitoring commit and push events, for example, by using secret scanners. And if secrets need to be provided within the repository, they should be encrypted. And we find that there are some typical steps that should always be taken to remediate an incident. We consider it mandatory to invalidate the leaked secret by revoking or renewing it to prevent further misuse. Then, analyzing the leak can help to identify and understand the root causes of the leak and may help to prevent future leaks. In consequence, the access management can be revised, for example, by applying a more restrictive access management if needed. And for legal and ethical reasons, concerned roles, such as management, security team, or the customers should be notified. In addition, if the leaked secrets were part of the source code, they should be removed. And the version control history can be cleaned up. So for service providers, they can, for example, be GitHub, or the platforms where secrets are issued, for example, AWS, should provide information about code secret leakage prevention and remediation, because this is a place where developers assume they will find this information. And finally, developers were overall satisfied with GitHub's inbuilt secret scanner, so expanding this feature seems to be helpful. Thank you for your attention, and I'm happy to take your questions now.